Hi students, welcome to our physics channel Physics Star. Okay, today we are going to discuss one more interesting problem that is based on rotational collisions. Now let us see the question once. That is a circular wooden hoop of mass small m and radius capital R rests on a frictionless surface. A bullet also of mass small m and moving with a velocity v strikes the hoop and gets embedded in it. The thickness of the hoop is much smaller than capital R. Find the angular velocity with which the system rotates after the bullet strikes the hoop. Hoop means what? It's a ring. Okay. And he's saying that the thickness of that ring is much smaller than that capital R. We need not to consider the thickness of that hoop. Okay. We need to just consider the radius. And hoop mass is small m, as well as particle which is hitting that hoop is also of mass small m. Okay, now that particle is coming with a velocity v and it is colliding with that hoop, and that hoop is kept on a horizontal surface. Horizontally it is kept flat like that. Now the ring is like this, it is kept flat. Now when it hits that, we may observe two types of motions in that hoop. Am I right or not? Both translatory as well as rotatory motions. Am I right or not? Because it is not fixed to any particular axis. It is not hinged. It is not fixed to any axis. So we can say that both translatory motion will be there as well as rotatory motion will be there. Now in order to solve it, what we have to do? In general, I already told you in my previous lecture that when a particle hits a rigid body and that rigid body is not hinged, it is free to rotate as well as to translate. Now when it hits that, then automatically what we have to do in order to find out either the linear velocity, velocity of center of mass, or angular velocity, or coefficient of restitution, these values if we want to find out, there is some procedure. First one, let us find out let us apply the conservation of linear momentum. According to that, we are going to get the velocity of center of mass of that hoop. And the second one is we are going to apply law of conservation of angular momentum, and because of that we are going to get angular momentum with respect to center of mass only we have to consider. So let us start discussing that solution now. Let us start discussing. Now let us applying conservation of linear momentum. Simply, no need of calling it as linear momentum, simply momentum. So we can write that m into v plus, its first particle is moving with velocity, right, v, and the hoop is at rest initially before collision, right, so its momentum is 0, and after hitting, let us assume that it is this disc is moving with a certain velocity vc, means the velocity of center of mass. So I can write now, after collision he is saying that the bullet is hitting that hoop and gets embedded in it. It means that after hitting, both hoop as well as bullet will move combined, right? So I can write now 2m into m plus m, 2m into vc, velocity of center of mass. Okay, so m gets cancelled and I can get vc is equal to v by 2. vc is equal to v by 2. Now we have got that vc value, velocity of center of mass. Now let us suppose if we apply conservation of angular momentum. Now applying conservation of angular momentum, if we apply, then what I have to get? See, first particle. So particle is hitting that at a distance capital R, right? So that angular momentum, conservation of angular momentum with respect to center of mass. While we are applying conservation of angular momentum, only with respect to center of mass I have to find, right? So center of, with respect to center of mass means what? After hitting this, bullet comes to this position. The bullet comes to this position. So now here is a hoop, here is the hoop, as well as here is that bullet. Am I right or not? So the what is the center of mass of these two particles? Means this is completely embedded in it. So therefore the system center of mass, the center of mass of the entire system is at this position. Yes or no? So at what distance it is there? It is at r by 2 distance. Let me write it clearly. It is at r by 2. It is at a distance of r by 2, either from the center of hoop or from the bullet. Okay. So now with respect to that C, we are going to apply conservation of angular momentum. Okay. Now how to apply that conservation of angular momentum? That is m v. First let us take the particle before colliding. M v into what is its distance from the center of mass? R by 2. Yes or no? The distance means, see here it is colliding at this position. So this is the distance. Am I right or not? So therefore m into v into r by 2 is equal to, that is the initial angular momentum, and initial angular momentum of hoop is not there, right? It is at rest. Therefore I am taking that as 0. Now let us take after collision, after hitting that, then what happens to angular momentum finally. So if I apply conservation of angular momentum, that is m into, okay, now consider it is I omega for both the particle as well as a hoop. Okay, now I am taking I omega. Let me write it clearly. I1 means what? Particle, or else you may consider it as IP, means moment of inertia of the particle, plus IH, moment of inertia of hoop, into omega. Now let us write that mv capital R by 2 is equal to, what is IP here? Moment of inertia of particle with respect to what? Center of mass. So that I can write, now it is m r by 2 whole square, mr square only, no, because hoop is a ring. So with respect to center of mass, what is the distance of it? Means center of mass of the two particles, it is at a distance r by 2, mr square, that's it. Sorry, p and particle, p means particle, so it is mr square, simple. Then what about hoop? For hoop, with respect to center, with respect to C, I have to calculate moment of inertia of that entire hoop. Means with respect to this axis, if you observe, with respect to this axis, with respect to this axis. Understand? So now I am going to find moment of inertia with respect to that axis. How to write that? That is according to parallel axis theorem. That is first IC. What is IC here? M R square plus, okay, now IC plus MR square. What is that? Perpendicular distance between those two axes. The axis which is passing through center of mass is 1. Center of mass is 1. That is what we have to find. Okay, now. So for the entire ring about its own axis, its moment of inertia is mr square plus m into small r square. What is that small r? Means distance between two parallel axes, that is r by 2 whole square. Mr square plus m into r by 2 whole square. For the whole system, we have to take omega common. Yes or no? Because for the whole system, entire system is rotating about its center of mass, right? So therefore, both sides m is there, and I am going to cancel this m. Okay, v into r by 2 is equal to r square by 4 plus r square plus r square by 4 into omega. See, both sides r will also be cancelled, right? Therefore, now I can write v by 2 is equal to r by 4 plus r by 4, r by 2, r by 2 plus r. R by 2 plus r is what? 3r by 2. Am I right? 3r by 2 into omega. Therefore, 2 and 2 gets cancelled. Therefore, angular velocity omega is equal to v by 3r. That's it. This is angular velocity, okay, after being collided by particle of mass m, means bullet of mass m. So first what we have done, first we have applied law of conservation of linear momentum. While we are applying law of conservation of angular momentum, we need to take care. We need to consider only center of mass of that entire system. Why? Because bullet is being embedded in it. Okay. So that we need to consider the center of mass of that whole hoop plus bullet. Center of mass of that whole hoop plus bullet is what? Exactly at the center, because both of them have same mass. So about that C, I am going to calculate, I am going to apply conservation of angular momentum, and finally I have got it as omega is equal to v by 3r. That's it. So this is about that solution. Please keep watching my channel. For updates, please press bell icon. Please like, share and subscribe to my channel. Thank you.